Okay, we're just going to look at some other questions from this exercise. Let's look at, again, exercise 6.2. I just want to look at question 30. So exercise 6.2, which is rates involving two or more variables. Just want to look at question 30, just with the diagram for this, just to start you off. So it says a rectangular block of ice with a square base. So it's like it's a square prism. It's like that. So a rectangular block of ice with a square base has a height, oh, I've actually drawn that really badly. The height is only half the size of the base, so I shouldn't draw it like that. Has a height half the side of the base. So we've got a few options here. We can either let the base, so if we've got x, yeah, we're on question 30 actually. So a rectangular block of ice with a square base has a height half the side of the base. So what are you going to let the base be? Well, if you let the base be x and x, the other one's x on 2. Do you really want to be dealing with fractions? So I'd go, so you can go x, x, x on 2, but I don't like that. I think that you should do, you can go 2x, or you can call it s, it doesn't matter. You can go 2x, 2x, x. I think it's gonna be a lot nicer to work with if we do that. So a rectangular block of ice with a square base has a height half the side of the base. As it melts, the volume of the block is decreasing, and find the rate at which the surface area will be increasing when the side of its base, actually we've got to be careful here. If the side of its base is 2.1, then we've got to be careful here. Maybe we should just stick with the first diagram. Doesn't matter about x on 2. Stick with the first diagram. Because, see, the side of the base is 2x, and I'm just really worried, how are you going to substitute 2x with 2.1? You'd have to put half of the 2.1 in. So I wouldn't be going there, okay? I'd stick with this. Okay, so just coming up, so what's it asking you, or what information do you have? So we've got x, x, x on 2. As it melts, the volume of the block of ice is decreasing at that rate. What does that mean? dV dt is negative, because it's decreasing, negative 12 centimeters cubed per second. It says find the rate. What else do we need? We need a few other things. We're talking about, that the question involves volume and it involves surface area. So why don't we work out the volume and the surface area? Write out the formulas. You need to write them out both. Formula for volume is what?
Height times base.
Yeah, those three multiplied by each other. So it's x times x on 2, which is x cubed on 2. And if we've also, what do we need? Another formula for the surface area. So we've done our, so we're just surface area. So we'll need a formula for that. Surface area is what? So we've got volume is x cubed on 2. We'll have to do something with that later. What's surface area? Surface area is
2 times x squared.
Yeah, 2 lots of the x squared plus 4 lots of those side ones. 4 times
x times x on 2.
Yeah. So it's 2x squared plus 4x squared on 2 is just another 2x squared. Surface area is 4x squared. That's nice and easy. So now what do you do?
ds
dx, and you'll do dv dx as well. So ds dx is 8x, dv dx is 3x squared on 2. Remember, the 2 is just a constant. Now the question says find what? D what?
ds dt.
Yeah, when x, which is the side of the base, is 2.1 centimeters. Okay, all the units look fine. We've got centimetres cubed per second, centimetres, everything's fine. Can you see why we couldn't let the base be 2x? Because
When you
we'd have that 2x would be 2.1 in this case, if we did keep with that 2x thing. So ds dt, just, well, you have to have the ds quantity on top. What are you going to write? dsd. What's the only thing you could really put? You've got three quantities, dv dt, dv dx, ds dx. What do you have to put? You've got the ds, so you have to start with the ds. ds d what?
ds dx.
That's the only thing you've got. Now we have to undo the dx. So what would you put next?
Dx.
dv. You can flip it. You'll flip the dv dx. Now the dx is cancelled. What else has to cancel?
The dv.
So you put the dv.
dt.
Okay, so they cancel, and it's good. You've got ds dt, which equals, now substitute. ds dx is 8x. dx dv is the flip of that, so it's 2 over 3x squared. And dv dt is negative 12. So you'll get something for that. Well, 3 goes into 12 4 times. What have we got? 8, 64. Negative 64 over x. And now you substitute. So when x is 2.1, ds dt is negative 64 over 2.1, which is whatever you get.
Negative 30.48.
Yeah. So therefore, you write a conclusion. Surface area is decreasing at a rate of 30.48. What would the units be? Because it's area, centimetres squared per second. Yeah, question 31. A 4-metre long ladder is leaning against a wall. So you really need to draw up a diagram. So there's your wall, there's your floor, and the ladder is 4 metres long. So a 4-metre long ladder is leaning against a wall. Its base is slipping away from the wall at a constant rate of 2 metres per second. So this base is moving away at 2 metres per second. Now that's a D, you can call it X, you can call it whatever, a dx dt. But, you know, we've got to work out what we're going to do with that in a minute. At what rate to 2 decimal places will the top of the ladder be slipping down the wall when the base is 1 metre out from the wall? Okay, so the 4-metre long ladder is leaning against the wall. We're really going to have to give these quantities, label them somehow. You can probably do it X, and this distance here is Y, that distance there. Okay, so we've got a 4-metre long ladder is leaning against the wall. Its base is slipping away from the wall at a constant rate of 2 metres per second. Now, we know the distance of the base of the ladder from the wall, it's X. So you know this sentence, its base is slipping away from the wall at a constant rate of 2 metres per second. What do I write there? D what? D what? Yeah, it's dx dt. And do you think that that distance is increasing when the ladder slips away from the wall? So it's positive. So we know that dx dt is 2 metres per second. All right. It says at what rate to 2 decimal places will the top of the ladder be slipping down? What are they asking for? We know that this distance is d is y, so they're looking for, they want us to find what? At what rate will the top of the ladder be slipping down when the base is 1 metre from the wall? So what are they asking us for? Find d.
dy dt.
Yeah. When the base is 1 metre out from the wall. When what? the distance of the base from the wall is defined by x. So
X equal 1.
yeah, when x is 1. We've got this dx dt, find dy dt. The problem is we don't know what y and x are. How can we find what y and x are? Pythagoras' theorem, yeah. So you'll come up with expressions for y and x using Pythagoras' theorem. So we know that x squared plus y squared is 4 squared, or 16. So therefore, y squared is 16 minus x squared. Y is the square root of 16 minus x squared. And similarly, what do we know about x will be?
16 minus 1.
I'm not even sure if we need it anyway. Similarly, x will be the square root of 16 minus y squared. Not sure if we need that anyway. Okay? Our little formula. dy dt, because you're starting with dy, you must do the dy quantity first, is the same, equals dy d. What do you think? dy dt is dy d. Well, what can you find with dy?
Dy dx.
Yep, we still have to find that, times, well, how are you going to get dy dt? Well, we need a dx up here, dx d, what have we got?
Dx dt.
Yeah, we've got dx dt, so you actually don't need this, not needed. So all we've got to do is work out what dy dx is. So we know that y is 16 minus x squared to the power of. So y is the square root of that. How do we differentiate that? To the power.
So negative 2x.
No.
To the power of a half.
Good. So dy dx is, bring half to the front, a half bracket 16 minus x squared to the negative a half times.
Negative 2x.
That's right. So the 2's cancel and this negative a half goes down the bottom. So you've got negative, oh, I can write it all out, 2x over 2. And this would be the square root of 16 minus x squared. And you can simplify that, which is negative x over the square root of 16 minus x squared. So that's what dy dx is. So now you can come back over there and finish it off. So you can substitute in this dy dx, it's negative x over the square root of 16 minus x squared, and dx dt is 2. So we can sub x is 1 because you need to find dy dt when x is 1, and you will get that dy dt is negative 1 over the square root of 16 minus 1 squared times 2. So it's negative 2 over root 15, which is, I believe, negative 0.52 meters per second to 1 decimal place. So interpreting that in light of the question, therefore the base of the ladder is slipping. See, it's a negative answer because if you look at y, the ladder is going to move down like this. So y is decreasing, the distance y is getting smaller with time, but x is increasing with time. So that's why we've got a negative answer here. So the base of the ladder is slipping at the rate of 0.52 meters per second. So every second it's dropping down half a meter, roughly. An observer, question 32, just going to do this one last, sees a plane directly overhead 2 kilometres above the ground. So here's the ground, 2 kilometres above, we've got the plane. Okay, now I'll call this P1, where the plane is at point 1. The plane is moving horizontally at a constant speed of 500 kilometres per hour. So we'll go to the right because it's a positive. So then we end up here. Okay, so it's going this way, and its speed is 500 kilometres per hour. Now, this speed is d watt, d watt. I'm going to call this distance x because we normally let displacement equal x. What speed? D x, d what? Speed. Look, distance over. Look at the units. Oh, sorry, I don't go. Yeah, so the speed is dx dt. It's the velocity is 500 kilometres hour to the -1. So we've got this diagram here. When you look up, the person standing here looks up, the plane is directly 2 kilometres ahead. The plane is travelling at a speed of 500 kilometres an hour. I don't know what that distance is. I just know that the plane's going across there at a speed of 500 kilometres an hour. My units seem okay. Kilometres per hour, kilometres is good. It says find the rate at which the distance will be increasing between the observer and the plane when the distance between them is 5 kilometres. So I've got 2 kilometres y, x. I'm going to call this distance here y. So let y equal the distance between the person and the plane. I'm just going to start you off on this. So do you think you can come up with a formula for y?
Pythagoras.
Yes, use Pythagoras to come up with a formula for y. So y squared is 2 squared plus x squared. So y is the square root of 4 plus x squared. So therefore you'll be able to find dy dx. So y is x squared plus 4 to the half. You can find dy dx. Let's just see what the question's asking us to find. Find the rate at which the distance will be increasing between the observer and the plane. So what are they asking for? D what? D, find the rate at which the distance will be increasing between the observer and the plane. Dy dt. So the question is asking you to find dy dt when the distance between them is 5 kilometres. When what is 5?
X.
No, the distance between them.
Oh, y.
When y is 5. Okay, so you've got enough information there to do it. So you want dy dt. So dy dt is dy d what? Well, you've only got a few quantities. What do you think you can do here? Dy dx is a half. X squared plus 4 to the negative a half times 2x, which is, the 2's cancel, and you get x over the square root of x squared plus 4. That's what dy dx is. Do we know what to do now? Dy dx is that, so it's x over the square root of x squared plus 4. So dy dt is dy dx times... Yep, actually I've got a lesson, I've got to go. And then you can substitute those in. So it's x over the square root of x squared plus 4 times dx dt is 500 kilometres an hour. And then you all right, we can't do the substitution for x, but we can work out what x is when we know that y is 5. See how we have to substitute what x is here? We can't. You have to find dy dt when y is 5. But if we know when y is 5, we can work out what x is. Do you see that? Using the diagram. So I've got this diagram here. Y is 5, x, 2 and x. So find x when y is 5. We get that x squared is 5 squared minus 2 squared. So x squared is 21. So x is the square root of 21. So we sub dy dt is x over the square root of x squared plus 4 times 500. We sub x is the square root of 21 into that formula. Does that make sense? Because you can't substitute the x value in. We didn't know what the x value was, but we come back to the right angle triangle because this is y. So when y is 5, you can work out what x is. So we get dy dt is the square root of 21 over the square root of the square root of 21 squared plus 4 times 500. That's the square root of 21 over the square root of, well, square root of 21 squared is 21. So it's over the square root of 21 plus 4 over the square root of 25, which is 5, times 500. So therefore it will be 100 root 21, which is 458 kilometres per hour. Okay? And that's that question. When I post this video, I will set the homework with it. Okay?